Homework 7, Chapter 6. And the first one that we have asked for from that chapter is number 6. Please let me know if you are unable to see the screen. So we are going to pay, let's see, a stock you're interested in paid a dividend of $1 last year. Can anyone tell me whether that is D0 or D1?
D0.
Very good. So I'm going to write some basic stuff down here, and then I'll turn it to where you can see the paper. The anticipated growth rate in dividends and earnings is 25% for the next 2 years before settling down to a constant 5% growth rate. So what kind of problem is this? Is this constant dividends, constant dividend growth, or supernormal or differential dividend growth?
It's supernormal.
Yeah, it's supernormal. Okay, so we've got the growth rate. The first one is 25%. And then the second growth rate is 5%. And then we have a discount rate of 12%. And they're asking us to calculate the expected price of the stock. So now I'm going to switch over and get back to the document cam. Oh, I need to spin this around. Okay, please let me know if you're having any trouble seeing the document camera. Can you read my writing? I'm going to take it. Okay, very good. Okay, so how do we start with something like this? First of all, they tell us that it's D0, but we know we don't get D0. We also know that we're going to work this out in our calculator. And so what we're going to do here is write out what these different things are going to be. But first thing I want to do is draw a picture. And we're going to use the kindergarten method. They tell us that that dividend that they give us is at time 0. And then they say for the next 2 years. And so I'm going to say 1, 2. And so that means we need to get these individual dividends. So we need D1 and D2. And then we're also going to need a P2 that's going to give us the price that represents at time 2 all the dividends that will be paid at time 3 going forward. And so basically we're going to have that D1 is equal to 1 plus G2 times our original D0. We're going to have that D2 is going to be equal to D1 times 1 plus G2. So that's all we need to know for the individual dividends. Now we need to know P2. And P2 would just be D3 over R minus G2. Sorry, should be 1 up here. Okay, so this should be D3 over R minus G2. Do we know D3? Can anybody tell me how we're going to get to D3?
By incrementing the dividends by the growth.
Yeah.
Supernatural growth.
Very good. Thank you. And it's going to be the second growth rate. And so that's going to be what we do for P2. And so what I want to do in my calculator is, first of all, recognize that we don't get the year 0 dividend unless they tell us otherwise. C01 is going to be equal to D1. C02 is going to be equal to D2 plus P2, because both of those cash flows happen at the same time. So I want you to go ahead and get your calculator out. If you haven't already, get that thing turned on. And we're going to hit CF, second, clear work. And for CF, 0, we're going to have 0. Then I'm going to arrow down. C01 is going to be D1. And so what I'm going to do is take 1 times 1.25, which is 1 plus our first growth rate, and that gives me $1.25. And I want to do two things here. First of all, I want to hit enter, and I want to hit store 1. That's D1. Now the next one is going to be D2 plus P2. Let's get down here. Oh, by the way, F01 is 1 because there are no two identical cash flows in this thing until we get out beyond where we're looking. Arrow down C02. Actually, there are no identicals at all because it's constantly growing past that. C02, we're going to do D2. Can anyone tell me how to get D2 given what I have here in the calculator?
Multiplying the growth rate with things that's stored in 1, I think.
Yeah, so we're going to say recall 1 times 1.25 equals enter. Now that gives us D2. But keep in mind, C02 needs to be D2 plus P2. How are we going to figure P2? Well, it's going to be this D2 we have right here. Sorry about my ring light here. I think we may just be stuck with that. Okay, so it's going to be this D2 multiplied by 1 plus G2. What's this G2?
0.05.
Very good. Okay, so I'm going to multiply this times 1.05, divide by, open parentheses, R is 0.12 minus that second growth rate, 0.05, close parentheses, equal. So I'm getting $23.44 here. I'm going to hit enter here, but we're not quite there. So this just represents P2. What do I need to add back to it?
D2.
Yeah, so we're going to say plus recall 2 equal. Uh-oh, that didn't work. Plus recall 2 equal. Okay, maybe I didn't store it then. 1.25 times 1.25. It was 1.5625, is that correct?
Yes.
Yes.
Okay, store 2. And then we're going to plus 20, what was it, 23 point, there it is. 1.525. So that's 25. So I'm going to go and put in 25 here. So that just represents D2 plus P2. Is anybody else not getting this number? Please let me know if anyone's having trouble. Okay. This is one thing I hate about Zoom. I can't see your faces to see if you're in pain or not. Okay, now, how am I going to figure out the net present value of all these things that we put in the cash flow register? Ms. Robinson, how am I going to get the present value for these cash flows that I put in here? Mr. Taylor, how am I going to get the present value for the cash flows we've been putting in here?
We're going to go second, net present value.
Okay, we don't have to hit second, but you're absolutely right. We're going to hit net present value. And what will we put in for I? Would it just be the return here?
Mm-hmm.
We're going to hit 12, enter, arrow down, compute. So that tells me that the answer is $21.05. Let's see. Come on. And there we go. There's our correct answer, $21.05. Okay, the student who requested this, does this make sense to you?
Yeah.
Very
We're
good.
good.
Okay, now I'm going to give you a little hint about what to do when you run into one of these on the exam. By the way, do you think this is difficult for students to get the right answer? Absolutely. And so what I would tell you to do is if you see this, skip it. Wait till the very end. This, I'm going to put at most one of these on the exam that I can think of. It'll be very similar to this. That's going to be 2.5% of your overall grade. There's going to be a lot of simpler stuff. So if I were you, I would just skip this one. Does that make sense?
Yes, sir.
Very good. Okay, now let's see. We also have a request for number 9. Turnip and parsley common stock sells for $31.65. Let's see. So P0 equals 31.65 at a market rate of return of 9.5%. So R is equal to 9.5%. The company just paid their annual dividend of $1.20. Let's see, Mr. Osawogwu, is that D1 or D0?
D0.
Very good. D0 is equal to 1.20. And they're asking what is the growth rate of their dividend? Oh, this gets nasty. Okay, so I'm going to stop sharing the screen now. And we're going to write out how all this relates. So we know that P0 is equal to D1 over R minus G. But we do not have D1. What do we have? We have D0. And so we're going to have to multiply by 1 plus G, divide by R minus G. My P's and D's look too much alike. Okay, now here is the problem. This variable that we're trying to find is actually in 2 places. And this usually freaks students out. But with a little bit of algebra, we can handle this with no problem. So the first thing I'm going to do is multiply both sides by R minus G. And that's going to give me P0 R minus G is equal to D0 1 plus G. Now the second thing I'm going to do is use the distributive property and say P0R minus GR equals D0 plus D0G. Someone stop me if I break any algebraic laws. I think so far I am good. Okay, now to get G by itself, we need to move this to one side and this to the other. And so what I'm going to do is say P0R minus D0, I'm just subtracting it from both sides, equal to, and I'm going to add GR to both sides, plus D0G. Have I blown any minds yet? Okay, so how can we get G by itself? Any ideas what we should do next? It's the opposite of distributing. And so I'm going to pull G out of here. And what will I be left with? R plus D0. And so now I can just divide both sides by R plus D0, and I get G is equal to P0R minus D0 divided by R plus D0. Okay, now let's go ahead and throw the numbers in there. P0R is 31.65. We're going to multiply that by R, which is 0.095. Always remember to use the decimal, not the percentage. Minus D sub 0, which is $1.20. Divide by R plus D0. That's looking weird. Let's see if it works out. 1.295. Okay, so here we go with the calculator. 31.65 times 0.095 equals 31.65 times 0.095 equals, I've got 3.00675 minus 1.2 equals, divided by 1.295 equals. I've messed something up here. I have definitely messed something up here. Let's go back and look through. So I multiplied both sides by r minus g. I distributed that, d0 plus d0 z.
When
Oh, there it is. There we go. Okay, so now, instead of moving GR over, I've got GP0. Does that look right?
Do you mind moving the paper a little bit to your right?
Like this?
Thank you. Yeah, thanks.
Okay, and so now that's GP0. There we go. And so G is equal to, and this should be P0 plus D0. And so on the bottom here, it should be 31.65 plus 120. Let's try this one more time. 31.65 times 0.095 equals minus 1.2 equals divide by 32.85 equals, and that gives us 0.055. And when I go back to share my screen with you guys again, we can see that that is the correct answer. Now, look at the way that they've done it here. They may do it in an easier way that you could deal with more easily. They went ahead and plugged in every number except for G, and then they just solved for G. And for most people, that's the best way to go. In fact, for me on a COVID day, apparently that's the best way to go. Normally, I'm better at just doing the algebra, but you need to figure out what works for you. Now, how about this? What would you think about just putting, and I'll show it to you here again. What would you think about just putting this formula on your formula sheet for in case you encounter one of these on your exam? That way you don't have to worry about plotting through the algebra like I did. Questions or comments? Okay, the student that asked for number 9, does this work for you?
Yeah, thank you.
You're welcome. Okay, so that is all I have for chapter 6. Are there any other questions from chapter 6 before we move on? I'm going to take that as a no. Okay, so let's go back now. Chapter 10, we have a request for homework number 8. Before we get done here, I want to show you how few of you have actually been doing the practices, and so I can tell you exactly how disappointed I am with you. Okay, a stock has returns of 3%, 18%, negative 24%, and 16% for the past 4 years. Based on this information, what is the 95% probability range for any one given year? As soon as you see a problem like this, what distribution should pop into your head?
Normal.
Yeah, the normal distribution. And so in order to make the normal distribution work, the first thing we're going to have to do is find the, see, am I sharing that with you? First thing that I'm going to have to do is find the mean and the standard deviation for these returns. Let's see, who else is on board here so I can ask someone. Ms. Moreno, tell me how we're going to find the mean and standard deviation of these 4 returns.
The 4 returns, let me check my notes. You can ask somebody else as well.
I can ask someone else. Well, thank you.
I don't have my notes here.
Yeah, Mr. Herberholt, either one. Can someone tell me how I'm going to find the returns, the mean and standard deviation for these returns?
The normal distribution.
The normal distribution is not how we find mean and standard deviation, but we're headed in that direction. Can you tell me how to use the calculator to find mean and standard deviation of these returns?
Yeah, plugging it in the data and then using stat later on.
Yeah. Okay. So, yeah. Does that start to ring bells? So this is
Second plus 7. What's that? Was it that?
Second, 7. Now, what's the next thing that we need to do?
Plug in the returns.
No, we need to clear it
Second,
out
clear.
first.
Oh, yeah.
Right. And here's the reason why. We're given 4 returns here. What if the last problem we were given had 5 returns? There would be an extra return just waiting out there to give us trouble. So here's what we do. 3, enter, arrow down. What do we do for Y01?
Just leave it for this question, I think.
Yeah, just leave it because we only have 1 data series here. We're going to put 18, enter, arrow down for X03, 24, negative, enter, arrow down. And then the last one is 16, enter. So that's all my data. I'm going to just flip back through and make sure I got them all in there and that they look right, and they do. Now, Ms. Moreno, what is my next step?
Second plus 8.
Yeah, second, and then the 8 key, and it says Lynn, and we're going to arrow down. N means 4. We've got 4 samples, and that's exactly right. If that number is wrong, it means you need to go back and clear out and try again. X bar is 3.25. This is our mean. So I'm going to write down X bar equals 3.25. And then I'm going to arrow down, and the standard deviation is equal to 19.35. Have I blown any minds yet? I think this is all pretty standard stuff. Okay, now it asks for what is the 95% probability range. And if you think back to the normal distribution, we have plus or minus 1 standard deviation, plus or minus 2, and plus or minus 3. Between plus and minus 1, what percentage of observations do we have?
68.
Yeah, 68%. And between plus or minus 2, we have, anybody?
95.
Yeah, 95%. And between plus or minus 3, we're going to call it 99%. Now, the problem asks for the 95% probability range. So that means they want to know between -2 and +2 standard deviations. So now all we need to do is take 3.25 minus 2 times 19.35. That will give us the lower bound. And we're going to take 3.25 plus 2 times 19.35. And that's going to be the upper bound. So here's what I'm going to do on my calculator. I'm going to go ahead and say 2 times 19.35 equals, and I'm going to store 1. 3.25 minus, recall 1, equals I'm getting minus 35.45. And then if I do recall, let's see, 3.25 plus recall 1 equals 41.95. And so my range should be from 35.45 up to 41.95. Let's take a look at the answers and see if we got close to anything. There we are, minus 35.4 to 41.9%. So we got very, very close, and that there aren't any answers that are closer than that. Okay, so what were there? This is a multiple step problem. Number one, you've got to find the mean and the standard deviation. And you can do that with your calculator. It's easy, easy, easy. Number two, you have to use that information to construct your normal distribution, and then use that to figure out whatever the probability thing is that they're asking you to do. And so a lot of times students will, in fact, this is the problem that the Mongolian lady tried to pull me over the desk over, because it really, if you just look at it and you don't know about the normal distribution and you don't have it on your note sheet, there's really no way to do this. Questions?
So to clarify, if the question had asked what is the 99% probability, or if we had found that the standard deviation was 3 away from the normal, instead of multiplying by 2, would we have multiplied by 3?
Yes. So
Okay.
Let's redo this question. We'll just look at it. But if they had asked instead for the 99%, what you would have done? You would have just exchanged this out for the 3.
Okay, perfect.
Very good. Thank you for, and if they asked for the 68th percentile probability range, it would have been, this would have been a 1 instead. And those are only the 3 levels that I'm going to be asking you about. I will not be asking you about something that's 2.5 standard deviations away from the mean. Okay, now the next thing we see is chapter 11. Let's get to chapter 11.
Could I ask a question from chapter
Sure.
10?
Sure, yeah. Oh, yeah, sorry about that. What else do you want to see from chapter 10?
Yeah, I was not getting the variance for chapter 10, question number 3.
The homework?
Yeah, I'm getting standard deviation, but it's weird because my variance is wrong, but the standard deviation is correct. So
That is weird.
yeah.
And so you say number 3?
10. Number 3. Number 3, yes.
Okay.
The same problem. That's number 2.
Okay, so you guys are having the same situation? Okay, so it says it had returns. Oh, I'm going to share this with you. Come on. Uh-oh. That didn't work out. There we go. Okay, a stock had returns of 8%, 13%, and negative 3% for the past 3 years. Based on these returns, what is the approximate probability that the stock will earn at least 14.19% in any one given year?
My bad. I was meaning the practice chapter 10. Sorry, practice. Yeah.
Okay, here we go. Chapter 10, practice number 10.
3, yes, sir.
Number 3, sorry. Okay, you observed the following returns of Bennington Corporation stock over the past 5 years: 15%, negative 6%, 18%, 14%, and 10%. And they're asking for the arithmetic average, which is just the mean. They're asking for the variance, and they're asking for the standard deviation. So here's my thought to you. First of all, if they're going to ask you for variance, do things with decimals instead of with percentages, because it's easy enough to convert, but variance always looks funky if you do it with percentages. What you'd have to do is divide by 10,000 in order to get the number correct if you used percentages, because 100 times 100 is 10,000. But make your life easy. Don't do that. So here's what I would do for this one. I would go to my calculator and I would say, first of all, second data, second clear work. And now we have x01 is 0.15, enter, arrow down, x02, 0.06, negative, enter, arrow down, x03, 0.18, enter, arrow down. The fourth one is 0.14, enter, arrow down, and the last one is 0.1, enter. I'm going to make sure that I've got all those in there correctly. By the way, checking work seems like it takes extra time, but it saves you a lot of frustration. Okay, now, Ms. Moreno, what am I going to do next?
We're looking for the mean.
Yeah, the mean, the standard deviation. What am I going to do next?
Second plus 8.
Yep, very good. Okay, I'm going to arrow down. I've got 5, and that's good because I've got 5 samples or 5 sample size. My mean is 0.102. If I'm going to put that in percentages, all I have to do is multiply by 100, and it gives me 10.2, which is the correct answer. And then I arrow down, and the standard deviation, if I multiply this by 100, I get 9.50%, which is the correct answer. Now, can anyone tell me how I could get variance using this number?
Square it.
Square it. And that gives us 0.00902, which is the same as the answer on the problem. So the trick to that one is to just make sure you put these in as decimal. Anytime they're asking you to calculate the variance, work in decimals, not percentages. Does that make sense?
Yes.
Okay. Now, are there any other questions on chapter 10? Okay. Now we're going to move on to chapter 11. All of them that I've got here are from the homework. And the first one appears to be number 2. Baloo stock is quite cyclical. In a boom economy, the stock is expected to return 34% in comparison to 13% in a normal economy and negative 22% in recession. The probability of a recession is 15%, while the chance of a boom is 4%. What is the standard deviation of returns of this stock? Okay, so I'm going to make a chart, and I would advise you to do the same thing. And what I'm going to have is the state, the probability, and the return. Okay, so let's see, they're giving us boom, normal, and recession. The probability of a boom is 4%, 0.04. And they tell us that the probability of a recession is 15%, 0.15. They don't give us the probability of normal. How do we get it?
Add 0.04, add 0.15, and then -1.
Very good. So 0.15 plus 0.04 is 0.19. And so if I take 1 minus that, I get 0.81. And the reason she knew that to do that is that all these things have to sum to 1. Now they tell us the returns in each of these situations. For the boom, it's expected to be 34%. So we're going to say 0.34. For normal times, it's supposed to be 13%. And then in recessionary times, negative 22%. So negative 0.22. Now, can anyone tell me what our next step should be? Mr. Green, what should we do next? Mr. Oomfleet, what should we do next?
We multiply the probabilities by the returns, right? And then
Yeah.
add it up.
So to get the expected return, it's just going to be the sums from I is equal to 1 to 3 in this case of the probability of the state times the return in the state. And so we've got 0.04 times 0.34 plus 0.81 times 0.13 plus 0.15 times negative 0.22. So here's what I'm going to do. I'm going to go through here and I'm going to figure each one of these and I'm going to store them 1, 2, 3, and then I'm just going to add them all together to get what I want. Okay, so 0.04 times 0.34 equal store 1. If you're getting different numbers than me, let me know. 0.81 times 0.13 equal store 2. 0.15 times 0.22 negative equal store 3. Now, how am I going to get the sum of all those?
Recall 1 plus recall 2.
Yeah, recall 1 plus recall 2 plus recall 3. I'm getting 0.0859. Is that what you're getting?
Mm-hmm.
Very good. By the way, this is the laser pointer I use to taunt my dogs. Okay, so 0.859. Now, Mr. Jaquez, can you tell me what you think the next step is going to be?
Do we square it?
Oh, you're getting close. What do we have to do before we can square anything?
Subtract.
Yeah. So we're going to have to take the return minus the expected return to get this deviation. And that's what we're going to square. And so after that, then we'll have our deviation squared. And then what's the very last column that we're going to calculate?
Product multiplied by the probability.
Yeah, the probability multiplied by the deviation squared. Now, I could go through and do each one of these columns, and that's probably what most students would want to do. But we're going to, we have an easier way. We're going to say 0.34 minus 0.0859, which is that expected return we just found. And I get 0.2541. If I make a mistake here, shout out before I get too far along. So I'm getting 0.2541 for that. Now, what button am I going to hit next?
Square.
Yep, I'm going to hit square. And that's giving me 0.0645. And by the way, 0.0646. Don't write this stuff down. The only reason I'm writing it down is so you guys can see it later. Okay, now the last step is to multiply by the probability times 0.04 equals. And I'm getting this 0.0025826 da 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 da. What should I do with that number?
Store it.
Yep, I'm going to go ahead and store it in 1. We've already finished using what we had in 1. So store 1. There we go. Now the next one is 0.13. What do I subtract from that? Ms. Bergner, what do I subtract?
.0859.
Very good. Thank you. And that gives me 0.0441, which is what goes here. What do I need to do to that number next? Ms. Neuenschwander, what do I do with that next?
You're gonna square it.
Very good. And then what do I multiply by, Ms. Neuenschwander?
The probability.
Yeah, and the probability is 0.81 equal. And what should I do with this number?
You're gonna store it too.
Yep, store 2. Very good. Thank you. The next one is 0.22 negative minus. Mr. Bowrichter, what do I do next?
You add the 0.0859
We add it or subtract it?
or subtract it. I mean, yeah.
Okay, and now that I've got that number, what should I do?
Square it.
Square it, and then what do I do?
Multiply by the by the probability, which is 0.15.
Yep, and that's going to be store 3. So I've got this stored in location 2. I've got this stored in location 3. Now, I have all that stored. Sure, yeah. How am I going to figure out the variance of this thing?
Add store 1. Oh, sorry. Recall 1, recall 2, recall 3.
Recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.018194 d. And then how am I going to get from there to standard deviation?
Take the square root.
Yep. Take the square root and it gives me 0.134888, which is 13.49%. And when we go back to our problem, we can see that that is the correct answer. Does that work for everybody? Anybody have questions about that? So the secret about this, did I really have to write anything down? I might have written the expected value down, but typically what I do is I put it store 0 and then I subtract it every time. So really you should be able to do this problem without ever writing anything down, except for I would go ahead and draw out this table to get your probabilities and returns set correctly. Are there any questions? Okay, now the next one we've been asked about is question 3. You have a 2-stock portfolio with an expected return of 11.7%. Stock A has an expected return of 13.8%, while stock B is expected to have a return of 9.2%. What's the portfolio weight of stock A? Okay, so we know, let me stop sharing here. We know that the return on a portfolio is equal to the return on A times the rate of A plus the weight times the rate for both. Now, I also know something else about this. What do both these weights have to equal to if I add them together?
1.
1. So here's what I'm going to do. I know that XA equal X or plus XB is equal to 1. And so I can say XA is equal to 1 minus XB. Or I could say that XB is equal to 1 minus XA. I'm going to do this second one, and you'll see why here in a second. And I'll go ahead and tell you the reason is that we're being asked for XA, so I'm going to keep everything in terms of XA. If you did it opposite, it would be easy enough to do the subtraction at the end. And so I'm going to say now the return on the portfolio is equal to XA RA plus 1 minus XA times the return on B. And so now I can start filling in some numbers since I know some numbers. The return on the portfolio, they tell me, is 11.7%. And in this case, we can use percentages, but you could use decimals if you're more comfortable. We don't know X of A, but we do know the return on A, which is 13.8%. And then we have 1 minus x sub A times the return on B, which is 9.2%. Now I'm going to use my distributive property. 11.7% is equal to, and I'm going to scratch out these percentages because after all, those are going to cancel, and I'm tired of talking about them. So I've got 13.8 XA plus 9.2 minus 9.2 XA. All I did was use the distributive property here. 1 times 9.2 gives me 9.2 minus XA times 9.2 gives me minus 9.2 XA. Now, what should we do next? Mr. Holman, what should we do next?
Put the x sub A variables together and also get the 9.2 over with 11.7.
Yeah, so we're going to do two things. We're going to subtract 9.2 from both sides. So if I've got 11.7 minus 9.2, that's going to give me what, 2.5 over here. And then on this side, I've got 13.8 minus 9.2 equals 4.6 x sub A. Does that look good? Does that look okay to everybody? Okay, what's the last step? Mr. Green, are you back with us? I guess people didn't think that I would actually call people out today, huh? Ms. Ware, what should I do next?
Divide by 4.6 on both sides to get 0.5435.
Yeah, 0.5435, which is 54.35%. And if we go back to the screen, boom. Come on. There it is, 54.35%. Any questions about that one? So the whole trick there was just remembering that the weights always add to 1. Okay, now we're on to number 7. What's the return on a portfolio which is invested 20% in stock A, 50% in stock B, and 30% in stock C? Okay, now this looks like it's going to totally freak you out. And I guarantee you that this is something you should save till the end, but it's not nearly as nasty as it might first seem. Here's what we're going to do. We're going to figure out the return for the portfolio in each state of the economy. And then we're just going to treat that portfolio as if it is a single stock to get our expected return on that. And actually, the way I'm going to set this up would make it very easy then to solve for variance. In fact, that's what I thought we were looking for here, but it's actually quite an easy one. Maybe the next one's the variance. Okay, so here we go. I know that the expected return on a portfolio is just the weights times their expected returns. Okay, so the weight on stock A is 20%. And this return for stock A in the first boom scenario is 0.18 plus the weight on B is 50% times the expected return on B in the boom is 9% or 0.09 plus, by the way, did they even have to tell you 30% on stock C? We know those weights have to add to 1, so I didn't even have to tell you that. 0.06. Now this is for boom. And so the expected return for boom, we're going to calculate that out. But here's the way I'm going to do it. just to make the math easy for me so I don't mess things up, 0.2 times 0.18 equal store 1. 0.5 times 0.09 equal store 2. 0.3 times 0.06 equal store 3. So then I'm going to say recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.099. Is anyone getting something different? Speak up if you're getting anything different, please. Okay. Now, the next state of the economy was normal, and the weights are all the same, but the returns are different. And so this time we've got 0.11, 0.07, and 0.09. And so once again, I'm going to go through here. I'm going to say 0.2 times 0.11 equal store 1. 0.5 times 0.07 equal store 2. 0.3 times 0.09 equal store 3. Recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.084. Is anybody getting a different number than that? Okay, and then finally, we need to talk about recession. Once again, the portfolio weights are the same. In recession, this one has got minus 0.10. This one has 0.04. This one has 0.13. So here's what I'm going to do. I'm going to say 0.2 times 0.1 negative equal store 1. 0.5 times 0.04 equal store 2. 0.3 times 0.13 equal store 3. Recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.039. Ms. Baldwin, is that what you get?
Yeah.
Very good. Okay, now we went through all of that. How then would I find the expected return for the portfolio for overall? This is per state. I'm going to go expected return of the portfolio is equal to the probability of the boom 0.20 times the expected return in a boom 0.099 plus what's the probability of a recession or of normal is 70%, and then a return in normal times is 0.084 plus the probability of this last one is 0.10 times return in that state is 0.039. So now I can go through, say 0.2 times 0.099 equal store 1. 0.7 times 0.084 equal store 2. Make sure I got that one right. 7 times 0.084. Okay. And then 0.1 times 0.039 equals store 3. How do I get the expected return on the portfolio with those numbers?
Recall 1.
Yeah, recall 1 plus recall 2 plus recall 3. I'm getting 0.0825, which is 8.25%. And if we go back to problem, that is the correct answer. Questions?
We will get the same number if we would do instead of the expected return of each state of the economy on the expected return on each stock, correct?
Yeah, and so in fact, what you could have done is found the expected return on each stock. So let's talk about stock A. It would have been 0.2 times 0.18 plus 0.7 times 0.11 plus 0.1 times minus 0.1. And we would add all that together. That would be the expected return on stock A. And we do the same thing for stock B and stock C. And then we just go through and apply these weights, 20% times that expected return on stock A, 50% times the expected return on stock B, and 30% times the expected return on stock C. The reason that I went ahead and did it the way that I did was because when we start looking at if we were going to calculate variance or standard deviation, it's a whole lot easier if we do the portfolio and make it look like a single stock. But you're absolutely right.
Yeah, like question 8. Like I asked you through email, but I still cannot figure it out. Like I don't get the number.
Oh,
I
okay.
don't know. Yeah.
Well, heck, we're going to work that right now. Okay, so this one is going to be nasty. So I'm going to start with a clean sheet of paper. They ask us, what's the variance of portfolio consisting of 3,500 in stock G and 6,500 in stock H? By the way, what's the total value of the portfolio?
10,000.
Yeah, 10,000. So what would the weight on stock G be?
0.35.
It would
Very
be
good.
0.35.
Yep. And then what would the weight on stock H be?
0.65.
Yeah, 0.65. And then you can check your work by adding those together, make sure they equal 1. Okay, they tell us that we have 2 states of the economy. So this is going to make life a whole lot easier. Boom and normal, 15% chance of boom, 85% chance of normal. And then they give us the returns if the state occurs. And so we're going to take that information and we are going to first figure out the expected return for the portfolio in each of those scenarios. And then we are going to figure out the variance from there. So I'm going to take a little drink of water here and we'll get going. So we have the state, boom, and norm. We have the probability, 0.15, 0.85. Probabilities always have to add to 1. Now, we have the returns on these stocks. And so what we need to do is figure out what is the expected return on the portfolio in the boom. And we need to figure out what is the expected return on the portfolio in normal times. So the way I'm going to go about this is by figuring out. So we're going to have 0.35 times the return on stock G, which is 15% in boom time, so 0.15, plus 0.65, that's the weight on H, times the return on H, assuming a boom occurs, which is 0.09. So I'm going to go ahead and do that math. 0.35 times 0.15 equals 0.0525. I'm going to store 1. 0.65 times 0.09 equal store 2. And then to get the expected value, I'm going to say recall 1 plus recall 2 equal. I'm getting 0.111. Is anybody else getting that number or anybody not getting that number? Okay, I'm going to assume it's correct then. 0.35. This time we're looking at the return on stock G in normal times, 0.08 plus 0.65, the weight on H, times the return on H in normal times, which is 6% or 0.06. And we're going to do the same process here. 0.35 times 0.08 equal store 1. 0.65 times 0.06 equal store 2. Recall 1 plus recall 2 equal. I'm getting 0.067. Is that what you guys are getting?
Yes.
Yeah.
Very good. Okay. So now, how am I going to find the expected return on the portfolio overall? Anyone have any idea how to start?
By multiplying with the probability of the state.
Yeah, by going with the probability of the state. And so we've got 0.15 times 0.111 plus 0.85 times 0.067. So I'm going to say 0.015 times 0.111 equal store 1. 0.85 times 0.067 equal store 2. Recall 1 plus recall 2 equals. I'm getting 0.058615. Does that sound right? That does not sound right, does it? Let me try that again.
I got 0.0736.
Yeah, I think that's right. Okay. So just to make sure we got this, 0.15 times 0.111 equal store 1. 0.85 times 0.067 equal store 2. Recall 1 plus recall 2 equals. Yeah, there we go. Okay, now here's what I'm going to do. I'm going to say store 0 because that's the expected return that I'm going to subtract to get my deviations. And the deviation is going to go right here. And then after I figure out the deviation, what do you think I'm going to do with that?
Square it.
Yeah, we're going to square it. And then what's the final column over here?
Multiply the probability.
Yeah, probability times the deviance squared. Okay, so let's go ahead and do this. And I'm not going to write these down, but we're going to go all the way across. I'm going to take 0.111 minus recall 0. I'm getting 0.0374. I'm going to square that. I'm getting 0.00139 and some stuff. Now, the very last step, I'm going to multiply by the probability. I'm getting 0.0002. Is that what you guys are getting?
Yes.
Okay, I'm going to say store 1. I'm going to write my little 1 in a circle there. Now, the next one, I'm going to say 0.067 minus recall 0 equals. Then I'm going to square it and multiply by the probability, 0.85 equal. I'm getting 0.0000370026. Is that what you guys are getting? Did I mess that up? No, I think I got that right. So we're going to say
That's what I got.
okay, store 2. Now, how am I going to get the variance for this thing?
Recall 1 plus recall 2.
Yeah, recall 1 plus recall 2 equals. And I'm getting 0.00024684. And if we look at their answer, they're getting 0.000247, which is the same thing that we got. I'm telling you, it's a whole lot easier to get the expected return of the portfolio and then figure out the deviation, the returns on the, or figure out the returns on the portfolio and then figuring out the variance based on that, rather than trying to figure out the covariance between these things and using that 2xa x b covariance A with B, blah, blah, blah formula. Whole lot easier. Questions?
Yeah, so the first time I did this, I thought that I could do take the 3,500, 6,500 part at the end, but do you need to, it's really important to multiply those weights at the very beginning. There's no way to do it at the end.
Okay, so those are just the weights inside the portfolio. So if you go ahead and do, I don't even know how you go about it, but if you if you did stuff and then at the end tried to do something with that, you'd be in a world of hurt.
Right, that's where I was. I was so confused.
Yeah. Yeah, this is
All right, thanks for going over that one.
Oh, you're welcome. And if you want to watch this one more time, I have a video. It's an example video, and it says 2 asset portfolio. The first 2 minutes and 53 seconds is about going over the regular way. And then the last bit is how to do this thing. And so this thing, even though it takes longer to explain, it's actually easier to do. So I would recommend this technique instead of trying to find covariance or correlation. Okay, so we've got one in chapter. Oh, any other questions from this chapter before we move on? Okay, so now we've got a question from chapter 5. Chapter 5 homework. Oh, this is my online class. No wonder it's showing a lot of people actually did it. Okay. Question number 8. The value of a 20-year zero coupon bond with $1,000 face value when the market required rate of return of 8% compounded semi-annually is. By the way, I didn't even have to say compounded semi-annually because unless I tell you otherwise, we always assume we price zero coupon bonds as semi-annual. That's actually in one of your slides. Now let's talk about what this means. A zero coupon bond, how much is the annual coupon value of that? This isn't a trick question.
0.
Yeah, very good, it's 0. Now, because we're pricing it semi-annual though, what are we gonna have to do with that 20?
Double it.
Yeah, we gotta double it. And what are we gonna have to do with that market required rate of return?
Divide it by 2.
Yeah, divide it by 2. So I'm going to get my calculator right here. So I'm going to stop sharing my screen and go back to the calculator. First thing I always do for bond questions, second, clear TVM. I'm going to put in 40 for N. I'm going to put in 4 for I per Y. I don't have to put anything in for the payment because there is none. But if you wanted to, you could just say 0 payment. And we know 1,000 future value, and then we could compute the present value. And it gives us $208.29. Now, what's the most common way for students to mess this up? 10 N, 8 I per Y, compute PV. Well, that didn't even look right, does it? 0 payment, 20 N, 8 I per Y, compute present value. There we go. It would be off by a bit. Questions? Okay, before we walk away from bonds, I want to ask you this question. So we have semi-annual. We need to make 3 adjustments. What are the 3 things that we always have to do when it's a semi-annual bond? I'll get you started. We have to double something.
N.
Yeah, double the years to get in. And then we have to have. What do we have to do? Say again?
Payments.
Oh, okay. So the annual coupon amount. And what's the other thing that we have to cut in half?
I.
Yeah, so the yield to maturity to get I. And this is to get PMT. Now, most of the time, if I tell students this and I ask them to price one of these bonds, they can do all that just fine. The problem comes if I ask them to find the number of years, or if I ask them to find, say, the coupon rate, or if I ask them to find the yield to maturity, they forget to multiply by 2. They forget to multiply by 2. They forget to divide by 2 when they're translating backward. That's the biggest problem that I see with semi-annual coupon bonds. And I had one student, same student, I don't think she may have been in the online class, that emailed me about 2 different semi-annual coupon questions. And one of them was, I think, this thing, and one of them was this thing. And it all comes down to this right here. And so we have to translate to get the number of periods, and then we have to translate back to turn that into number of years. So these are all things to keep in mind. In fact, if you think this would be a good thing to have on your note sheet, I think it would. Okay, so we have worked every single question that was asked. Are there any more questions from chapter 5 people would like to see? Because we have like 3 minutes. Oh, I've got a chat down here. See what the chat says. Oh, it's Mr. Green. He says he was attempting to respond, but Zoom wasn't cooperating. Yeah, I get that. I've been there before. Okay.
Yeah, spacebar wouldn't work. Sorry.
Oh, I hate that. Okay, is there anything before we call it quits for the day?
So the exams are going to be like the last 120 multiple, like half multiple choice and half problems, or?
Okay, so it's going to be half conceptual. They're all going to be multiple choice. Half conceptual, half calculation, and we have 4 chapters. So you can expect 5 calculations from chapter 10, 5 concepts from chapter 10, 5 calculations from chapter 5. 5 concepts from chapter 5, 5 calculations from chapter 6, 5 concepts from chapter 6, 5 calculations from chapter 11, and 5 concepts from chapter 11. So that's how they break down. When we were talking earlier about this differential growth, and I told you guys to skip that, the thing to think about is that for the stock questions, I'm going to have 5 calculations for stock prices. Only one of them is going to be something that nasty. And so we're only really talking about people spend way too much time basically preparing for that question. And, if you're looking at spending your time efficiently and judiciously, that's not what I would recommend to you, is to spend a lot of time worrying about that one. Other questions?
When you're saying stock, you mean chapter 11, right?
So I talked to you about the dividend growth. That would have been in chapter 6.
Okay.
Chapter 11 was, and we did see a nasty one there with the finding the variance of the portfolio.
Mm-hmm.
That's another one that I would put up till the end, but keep in mind, I'm only going to probably throw one of those at you. And so if you just assume out of all these chapters that one of the 5 questions will be one you can't get for the calculation, just assume that. That still leaves you with 80% of the calculations. If you get 80% of the concepts, you're still hitting a solid B. And so there's no shame in that for sure in this class.